The question 17 is about normal distribution curves. And you might remember the same questions are there in the writing part, question number 4. So if you have watched that video, then this is the same thing again. The first type of problem is just to identify random variable in each distribution. Now we need to classify whether this is discrete or continuous, and we need to explain our reasoning. Now the number of texts received per week. Now whenever a quantity given to you is countable as whole numbers like 1, 2, 3, 4, so on, and it's countable, it's discrete. You can count it out. Whereas it will be continuous if it's like 1.5, 1.35, and so on. It's like in decimals. So this is a simple understanding. Say heights of students in a class or weight of students in a class. It's not discrete, it's continuous. Whereas number of texts received per week, you can count it. You might have received 100 texts. It's countable, it's discrete. So this variable, the variable is what? Basically text received. The number of text received can be represented by a whole number. So the random variable is discrete. Now number of likes for a web page is also discrete, absolutely the same concept. The height of a plant after a specific amount of time, this is not discrete, it's continuous. The height of a plant is the variable, that's what's required, right? The height of the plant may be positive value, be any positive value. So this is very important, it can be anything. So it's a random variable that is continuous. And now we will move on to the relative frequency table. See, here they have given a real world problem. At a fundraising dinner, the underside of 200 plates were randomly tagged with a sticker to indicate the winning a cash prize. The frequency table shows the number of winning plates for each prize. Construct a relative frequency table and graph the probability distribution. Now they have given you all the different prizes, the frequencies. We need to see, they have told 200 frequencies totally, 200 plates that are winning cash prizes. So if there is, they have tagged whether you win $5, $50, $100, or $1,000. Only one plate out of 200 wins $1,000. There are 9 people with 9 plates that is winning $100 and 40 with 50, and the highest number of people are winning $5. These are among those who get this winning plate, So relative frequency is very simple. You need to first see whether the total frequency is given. If it's not given, just add them all up. 50 plus 40, 150 plus 40 is 190, 199 plus 1, 200. Relative frequency table, relative frequency is given by division of 150 by 200, 40 by 200, 9 by 200. 1 by 200. If they give you the exam, what I would suggest is do this table entirely. So it's price, that is X, frequency, type it out, write it out, sorry, 50, 100, 1000, that is $1,000. Now frequencies are given as 150, 40, 9, 1. You do not need to show this, but I mean in writing, but you can if you want. The relative frequency be 150 by 200, 40 by 200, 9 by 200, and lastly 1 by 200. So whatever the answer you get in the calculator, just put it over here. Write it in decimal, it's fine. So here it will be 3 by 4, it's 0.75. Here it will be 41 by 5, that is 0.2. Now here it will be very less, it's going to be 9. 9 is about 0.045, I guess. And this is going to be 0.0, like 1% is 0.01, but 0.005, I guess. Now you guys please use the calculator and get the exact values, but write in decimal, because this is an important table with relative frequency. But now what next? You need to graph it by probability distribution. The x-axis is here, $5, 50, 100, 1000. Now here you cannot go more than 1. See, it's 1 is maximum, 0 is over here. This is like 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9. Same way you can write the other values here. Okay, it's not accurate, but you need to do it accurately with even spacings. Now, when it's 0 0.75, where is it at 5? 0 0.75 somewhere over here. You need to do a bar graph like that. And 0 0.2 is for 50, somewhere over here. This is 0 0.045, and lastly, very, very small. So that would be the answer. That would be the probability distribution. You can see here, let me just clear it off. This is more accurate. For phi, it was 0 0.75, whereas for 50, it's 0 0.2. Yeah, 0 0.045 was for 100, and 0 0.005 is for 1000. Here you can see they have told the bars are separated because they are discrete, they are whole numbers, right? Whereas if they're continuous, it would be a normal distribution graph. We will see that later. Another problem, here they have told an athletic director made a probability distribution of the heights of her team's basketball player and distributed a flyer that claimed that the majority of the players on the basketball team are 71 inches or taller. Is that true? Identify any flaws. Now look here, this is the probabilities, right? 71 to 75, you can see there is so much high, isn't it? And even over here 76 and 80. But in fact, if you see the next one, 66 to 61 to 65, 66 to 70, what are that probabilities? It's around more than 0.24. It can be 0.243 or something. What does this mean? 24.3% are 61.6, 61 to 65. 24 points so much are this range. About 26%, if you take it to the other side, 26% are 71 to 75. 26% are 76 to 80. So is this true? Majority, is that true? No, it's just 52% are about more than 70, 71 inches, whereas 48% are not. Now what did they do? They manipulated the data. They manipulated the data of the x-axis. See over here, they just shrunk this, they made these changes and made sure it looks like, okay, the 71 and 75 are much more higher, but in fact they have just manipulated the data along the y-axis and they have just reiterated. But if you write over here, 52% are only above 71%, whereas 48% are less than that. So it's not actually true. The scale of y-axis is misleading, because it shows the difference of probability. This looks more, but in fact they aren't, So that is the thing. And what about the sixth one? Here, the preliminary times for a 100-meter hurdles race are shown. This is shown here. Create a histogram of a set of data, determine whether the data can be approximated with a normal distribution. Now, here you can see this is not discrete because there are decimal points, but normal distribution, let's see whether it can be or no. That's a very bad line. Let's draw a straight line and see what is the minimum value. Minimum value over here, 75, 31, 35, 25. 25 is minimum. So let's start with 14. And what is the maximum value? I got some 84, 93. So let's end it up at 15. So you can split it out evenly however you desire. I would write 14.1, 0.2, 0.3. Okay, that's not proper. But anyways, you get the gist of it, right? So now you see, okay, this would be 14.1 because here, I have done very oddly. Anyways, this is 5, 6, 7, 8, 9, and so 10. Okay, so here you can see there is how many 25? There's 125 somewhere over here. You have one bar. What next? Let me just write one point. This over here, x-axis, okay? About how many people? Oh, y-axis. This is the x-axis given. Now, what next? How many are there in the next range? I can see after this it's 35. There is again one more person at 35. Next is 40s. Where is 40s? There is no one. Oh no, there is 2 in 30. 31, 35, and none in 40. So then we will go to 50s. There is none in 50s, but there are few in 60s, right? Here there is 60s and 60s. Then 70s, there is a couple of them. Now see, they are in fact overlapping in the same range. You can write some over here like this. 80s, there are few. Now this is not accurate. I'll just show you the accurate graph and I'll show you here. See this. 1. There were how many ones? Let me just go back here. You can see these were all ones. Then there were few ones and then some twos and threes, and then I've not done all. Here you can see this is approximately 14.25. Then next range would be 14.25 to 35. And then see over here 14, there is 31, that is 1. From 3.5 to 4, another range. And then here we can see there is no points until we come to 6. 6 to 6.3, there is 1 point. Then 6.5 to 7.0 is another point. 7 to 7.4 you can say another point. And then 7.5, 7.7 can be plotted together. Whereas all the others over here, there are 3, 1, 2, 3 in the same range. The range approximately of these is 0.05 in the sense 14.70 to 14.75, and then, or you can take it as 7.4, then 14.75 to 14.879, and so on. That's the range. Okay, so this is how we can easily plot this up. There's nothing much. Now this you can see is skewed. This is negatively skewed because it's down, it goes up, and it cannot be approximated with normal distribution. There's no much data over here, so that's the thing, and it's not properly aligned. And normal distribution, now they have told about normal distribution, has a mean of 186.4 and a standard deviation of 48.9. What range of values represent the middle? 99.7. You need to know the normal distribution curve. Let's just look at it. This is the normal distribution curve. Here, the middle one is given, this symbol is mu, mu, okay, but it's pronounced as mu. It's a Greek alphabet. Even this one, it's a small letter sigma. You have seen this sigma notation before, right? This is like capital, imagine A, capital A, small letter A is like this. This is the small letter of sigma. So this is sigma mu. Now here the mean is given by mu. This is the center. Whatever is the mean, what is it? Given as 186.4, right? That is this point here. 186.4. And the standard deviation, each of this, see this lines, dotted lines, at the middle it's always 50%, 50%. Now if you add one more line, because there are majority of the values here, 34% is added to it. So 50 plus 34 is 84% data till here. That each additional line is given by the addition of sigma. That's over here. Sigma is given as 48.9. Now you need to know the middle part. C over here is given is 68%. Then if you add one sigma, it is 68% on both the sides. Let's add and subtract. Now if you add and subtract 2 sigmas to mu's, then it is 95%. If you add and subtract by 3 sigmas, it's 99.7. That is what we want. So now here it's very, very simple. You can memorize this value. 99.7 is given as sigma minus 3 pi. So the interval would be sigma minus 3, not pi, sorry, mu minus 3 sigma and mu plus 3 sigma. This is it. Now substitute the values. It's 186.4 minus 3 times 48.9. And here you have again 186.4 plus 3 times 48.9. Just find these values. That will be the answer. That will be the range of data that will represent 99.7. The 99.7 of the percent of the data. So here you can see it's 186. That's the mu minus 3 times 48.9. You get this, and here. So in this particular graph, for these particular values, this point, where is it? Sorry, 3. That's this over here, somewhere over here. Okay. See, it's not entirely 100%, but here it's 39.7 for this particular value, and over here it is 333.1. That's it. And the x value, see now this, any point over here we consider it to be x, because then we will solve the x value later on. X is given as whatever is z value. We require this for z value. We will see that later. Now it is within this range from 39.7 to 333.1, right? So x is less than this value, higher value, but greater than this. So we just write it like that. So that's the answer. Now what about this one? Again, let's see the normal distribution curve. They want to know what percent of data will be greater than 235.3. Where is 235.3? Let's try adding. Generally, it's always when you add once or twice, you will get it. If you add 186.4 plus 48.9, let's see, it'll be 40, consider this as 50, 30, 30, yeah, 36, yes, it'll be 235.3. I didn't do it approximately, but I know it'll be around 235, but obviously it's around that. So this is how much? Sigma plus standard deviation. Just once. Where is sigma plus standard deviation? It's more than, plus means it's the right side of 50%. This is 50% data, right? It's more than that. That's over here. So here it is 34%. This much is 50. So what percent data will be greater than, what percent? It'll be 84%. Why? Because you just add 50 and 34. Now here one important thing, I just realized it's greater than 235. So we need to find greater. What is this value? So how we find that is always, see, middle is 50%, right? 50% is known. How much is this point? From left side it is plus 34, that is 84%. Yes. But we need to know how much is remaining from more than that particular value, isn't it? So 100 minus 84% would mean 16%. So greater than this value would be 16% remaining data. So any value which is more than 235.3 or greater than 235.3 will be within the range of 16% only. So that is the answer. It's 16%. You do so much, 50 plus 34, it's 84, minus from 100, so you get the remaining data. You know, this much is 84, the remaining will be 16. The question number C is, what range of values represents the upper 2.5% of the data? Let's look into the normal distribution curve here. You know, this is 95% data, right? How much is remaining? There is 5% remaining, but 5% on both the sides. So each side will have 2.5%. Whenever they say upper 2.5, it's how much? Sigma plus 2 times, sorry, mu plus 2 times sigma. It's 186.4 plus 2 times 48.9. That would be the answer. Just put it in the calculator, you get the answer. So anything values more than 284.2% is the answer. Sorry, this is the mean value, right? When you add it, the data of 284.2 or more, that is representing the upper 2.5%. Now we have z-value problems. Here, these are very easy and simple problems. All you need to remember is one formula. Z-value is always given as x value. That will be either given or you need to solve it, minus mu, divided by what is remaining here? Sigma. Just these are the three things to remember. Now, z value can be positive or negative. If it's negative, it's in the left side of this normal distribution curve from its center, left. Positive is right. Now, let's solve this up. Here, since I've written the formula, I'll directly solve. Z value will be equal to 55.4 minus 68.34 divided by 9.8. That's the answer. Here, z value will be equal to 42.8 minus 68.2 divided by 11.6. That's it. You just put these in the calculator and you get the answers. You can see over here, you don't need to do so much substitution. Directly after substitution, after the formula, substitute, answer, only 3 steps. Even over here, the same substitution, directly answer. Now here both are negative values. That means it's in the left side of the normal distribution curve. Let me just show you here. That means minus 2 somewhere over here, you know, so many times sigma. Now 1 sigma 2, it's over here. So that's the thing. If it is 1.32, it is, you know, more than 1 but less than this somewhere over here. That's sigma value. So that's how we get the understanding of where exactly it lies in the normal curve. Even over here, it's the same formula. Now, you have been given z value of x value of 119.2 minus 112.4 divided by 11.9. Just put that in the calculator, you get the answer. This is positive because over here above it's positive, 0.57. Now here we have to use the table to find the area under the normal curve for each interval. See, these problems, you need to have a table. See, this table must be given to you. It's like a book or a page or a sheet, you know. If this is not given, it's not possible to find. I'm not sure how this question will be asked in your exam, because if they give you this, it's practically that's the answer. It's so easy. See over here, z value is greater than 0.58 from this table, which must be given to you. Otherwise, you cannot. The table must be given, you know. You don't memorize these values, they will be given. Now it's z value is 0. That's at the center. It's 50%. Now, if they ask you anything of z value at the center, 0.5, sorry, it's 0, 0.0. It's always 50% of the data. 0.5 is the answer. But here, they will ask you something else. If it's 0.58, then you have to look in this table, go down 0.5 and 0.58 will be going to the right towards the 8. This and this value will give you 0.58. What is the answer? 0.719. Now you need to find anything that's greater than 0.58, right? So greater than would be here, z value is 0.58. Z value is greater than. So you just have to know what is this point. What is that point exactly? From the table you get it as 0.7190. But you want to know greater. So total is 100. 100 means 1, 100% is 1 minus 0.719 gives you the answer. It's 0.281. That's it. If it was less than, then you just stop at this particular point. It's just 0.719. But you want to know the values greater than, right? Z values are greater. What interval? 100% minus this value. Even over here, you need to know this table. It's at the left, so it's C minus 1.5 and 6 is there. So it's minus 1.5006. That will be this value. So now you know this is the value. See, minus 0.156 is less than minus 2 over here. This particular distribution over here is 0.059. So then what do we need? It's just less than. So that is it. That is the answer. Because here whatever you get is from the left side. From the left side here it is how much? 0.0594. That's already known. That much percentage. If it was greater, you have to do 1 minus the remaining value. But here it's left side value that is already given over here as the answer. So another value, there are 2 points. So you need to find the z value for both these points. Basically, you see the table and find it. And if these values are given, that's it. That will be the answer. And then here, see, let's look into the graph. I'll show you. We got these two values, right? One was, okay, now since it's in between, you're dealing with what's in between. You can just write these two answers for z value of minus 2.29, this much to this much. Now, how would you exactly get this answer? That's very simple. Look over here. This is the curve. I know this is 1 point. Imagine this is 1 and this is 2. Just for, example's sake. Now, what is the distance between these two? It will be 2 minus 1. Same way, I know that point over here for the greater point is 0.9971 minus 0.0110. If you do this, you will get the answer 0.9861. That is your answer. So the values, the table under this particular, the area under these two z values is so much. So you can see that will be the answer. Now you can see here the yellow part is representing that from here to here. And the last problem here we have, it's an open response question. A normal distribution has a mean of 347.2 and a standard deviation of 13. It's just like what we had done a while ago. Mean is given as mu, standard deviation by sigma. What percent of data is less than this? Now, how can you find this? The easiest way would be trying in your calculator. I'm sure it's not one time. It's not one time 13 minus this. You should try whether it's two times, three times, four times. Let's take our calculators here. All you do is write 347.2 minus, I'll try with 2 times 13.9. Is it 319.4? Yes, it's not one time because it's just a little less. It'll be about 30 something. So this is the answer. So now we know, if we see the normal distribution, we can understand it. Because it was less than mean, I know it's left side. Sorry, let's go here. Because it's minus, less than the mean, it's minus here. So how much is the value? What percent of data is less than, means left side? What is this? From year to year, this much is 95. See, this, or do from the middle. 50 year, this much is 84 plus 13.5. It'll be 97.5, right? What is remaining here? What data is remaining? It is 2.5 that is remaining. Or else you can also see year to year, it is 5%, 95. So 5% is remaining. So half of 5 and half of 5. Half of 5 is 2.5%. So the first answer will be 2.5% only. That much percent of data is remaining below this particular value. Now, what percent is greater than 361.1? Again, let's take our calculators. Here now I'll start adding because it's more than this, right? I'll start adding. If it's 2, it's way more. No. So I need to subtract by once, add by only one times the standard deviation. And here you can see it's 361.1. So that means, sorry for that, it's this point over year 1. How much is from year to year? Half is 50. And here add this, it's 84%. Now we need greater than. They have clearly mentioned it's greater, not this answer. Greater, not 84. 100 minus 84% will be 16%. So that is your answer. So all the values that is greater than 361.1 is 16%. So there you go. So these would be the answers. That is how we solve the question number 17.